Problem 22, Quantum Mechanics. The question is, the ground state energy of a particle in a potential V of x equal to G mod x estimated using the trial wave function psi of x equal to root of c by a raised to 5 a square minus x square when x less than mod a, 0 x greater than or equal to mod a, where g and c are constant is. In the question, the ground state energy of the particle in a potential V of x equal to G mod x is asked using the trial wave function psi of x. This problem is solved using the variational principle. So to solve the problem using variational principle, that is to find out the ground state energy, we have to follow several steps. The first step is normalize the given wave function and find out the normalization constant. Then find the expectation value of kinetic energy. Find the expectation value of potential energy. Then write the Hamiltonian as expectation value of kinetic energy plus expectation value of potential energy. Then find out the value of A in the wave function using the equation dou by dou A of expectation value of H is equal to 0. Now once you find A, using the above equation, substitute the value of A in H, that is equal to expectation value of T plus V, to find out the ground state energy of the particle. These steps we have to follow. So the first step is normalize the given wave function psi of x. It is given that psi of x equal to root of c by a raised to 5 a square minus x square when x less than mod a. So in the wave function, the unknown value is c. So let us normalize the wave function and find out the value of c. To normalize, let us equate integral minus infinity to infinity. Psi star psi dx is equal to 1. It is not minus infinity to infinity. It is integral from minus a to a. Psi star psi dx equal to 1. That is c by a raised to 5 a square minus x square whole square dx equal to 1. Integral minus a to a. C by a raised to 5 a square minus x square whole square dx equal to 1, and that is equal to, we can write it as 2c by a raised to 5. Then the value of the integral become a raised to 4x plus x raised to 5 by 5 minus 2a square x cube by 3. Now let us apply the limit from 0 to a and equate this to 1. So this implies 2c by a raised to 5, a raised to 5 plus a raised to 5 by 5 minus 2a raised to 5 by 5, 2a raised to 5 by 3, this is equal to 1. This gives 2c by a raised to 5 into 15 a raised to 5 plus 3 a raised to 5 minus 10 a raised to 5 all divided by 15 equal to 1. This gives 2c by a raised to 5 into 8 a raised to 5 by 15 equal to 1. And after simplification, you will get the value of c as 15 by 16. When the value of c is 15 by 16, our wave function, that is the normalized wave function, is given by psi of x equal to square root of 15 by 16 a raised to 5, 15 by 16 a raised to 5, a square minus x square. This is the normalized wave function. So we have normalized the wave function, and our wave function is root of 15 by 16 a raised to 5 a square minus x square. Our next step is to find the expectation value of kinetic energy. We have to find out the expectation value of kinetic energy, then the expectation value of potential energy, and finally we have to write the Hamiltonian. So first of all, let us find out the expectation value of kinetic energy. Finding out the expectation value of kinetic energy. The expectation value of kinetic energy is given by h cross square by 2m integral minus a to a d psi by dx mod square dx. Already we have evaluated the value of psi, that is equal to root of 15 by 16 a raised to 5 a square minus x square whole square, a square minus x square. Now let us take the derivative d psi by dx, that is equal to root of 15 by 16 a raised to 5 into minus 2x. Therefore, the expectation value of kinetic energy T becomes h cross square by 2m, then integral minus a to a 15 by 16 a raised to 5 into 4x square dx. Now let us take the constant term outside, that is 15 h bar square by 32 m a raised to 5. Now we can write it as into 4 into 2 times integral 0 to a x square dx. That is equal to 15 into 8 h bar square divided by 32 m a raised to 5. Now the integral 0 to a x square dx is a cube by 3. Now let us simplify the expression, that is equal to 5 h bar square by 4m a square. That is, the expectation value of kinetic energy is 5 by 4 h bar square by m a square. Thus we have obtained the expectation value of kinetic energy. Now let us find out what is the expectation value of potential energy V. The equation for the expectation value of potential energy is integral minus a to a psi star V psi dx, that is equal to integral minus a to a psi star. Instead of V we have g mod x into psi dx, because the given potential is g mod x. Now substitute the value of psi and psi star in the integral. We have expectation value of V is equal to 15 by 16 a raised to 5 g integral minus a to a square minus x square whole square mod x dx. Since within the integral we have the function mod x, so let us separate the integral as 15 by 16 a raised to 5 g. The first integral is integral minus a to 0 minus a to 0, mod x become minus x, then the remaining part is a square minus x square whole square dx plus integral 0 to a x a square minus x square whole square dx. The first integral is given by minus 15 g by 16 a raised to 5. If you evaluate the first part, it is a raised to 4 x square by 2 plus x raised to 6 by 6 minus 2a cube x raised to 4 by 4 minus 2a square x raised to 4 by 4. And there is a negative sign also, because within the integral we have a negative sign. The second term is 15g by 16 a raised to 5. A raised to 4 x square by 2 plus x raised to 6 by 6 minus 2a square x raised to 4 by 4. Now apply the limit from 0 to a. In the first integral, there is a negative sign outside and the limit is from minus a to 0. So it becomes minus 15g by 16 a raised to 5. Now let us apply the limit. When you apply the limit, the first term becomes 0, so there is a negative sign. The second term is within bracket a raised to 6 by 2 plus a raised to 6 by 6 minus a raised to 6 by 2 plus the second term is 15g by 16 a raised to 5. Then apply the limit. A raised to 6 by 2 plus a raised to 6 by 6 minus a raised to 6 by 2. The first and third term will cancel in both integral. Therefore, our answer is 15g by 16 a raised to 5 into 2 times a raised to 6 by 6. Now, after simplification, you will get the expectation value of the potential energy as 15g by 16 into a by 3 that is equal to 5ga by 16. That is, the expectation value of potential energy is 5ga by 16. Thus, we have evaluated the expectation value of kinetic energy, expectation value of potential energy. Now, our Hamiltonian becomes the sum of these two. So, in the next step, let us write what is our Hamiltonian. We have evaluated the expectation value of kinetic energy, the expectation value of potential energy. The expectation value of the Hamiltonian H is the sum of these two. So let us write first the Hamiltonian. And once we find the expectation value of H, we can calculate the value of A, the unknown value of A in the wave function. Expectation value of H is expectation value of t plus expectation value of v, that is 5 h bar square by 4m a square plus 5 ga by 16. This is our expectation value of Hamiltonian. Now we have to evaluate A. We have to find out the value of A, which is the unknown parameter in the wave function. For that, take dou by dou A of expectation value of h is equal to 0 and find out what is A. Dou h by dou A equal to 0 gives 5h bar square by 4m minus 2 by a cube plus 5g by 16 equal to 0. This gives 10h bar square by 4m a cube equal to 5g by 16. This gives 5h bar square by 2m a square is equal to 5g by 16. That gives h bar square by m a cube equal to g by 8. Hence, a cube equal to 8 h bar square by mg. Therefore, A is equal to 8 h bar square by mg all raised to 1 by 3. Thus, we have successfully evaluated the value of A. We obtain the value of A. Once we obtain the value of A, let us substitute the value of A in the expectation value of h so that we will get the expression for the ground state energy. So in the next step, we substitute the value of A in expectation value of h, then simplify, and finally we will get the expression for energy. Expectation value of h is 5 h bar square by 4m a square plus 5 ga by 16. Now let us substitute the value of A in this expression. So expectation value of h is 5 h bar square by 4m mg by 8 h bar square all raised to 1 by 3 all raised to 2 by 3 plus 5g by 16, then 8 h bar square by mg raised to 1 by 3. And this is equal to let us simplify the expression. This is equal to 5 h bar square by 4m. Then we can write it as m raised to 2 by 3, g raised to 2 by 3 by 8 h bar raised to 4 by 3 plus 5g by 16, 8 raised to 1 by 3, h bar raised to 2 by 3, m raised divided by m raised to 1 by 3, g raised to 1 by 3, that is equal to 5 by 4 into 4, h bar raised to 2 by 3, m raised to minus 1 by 3, g raised to 2 by 3, plus 5g by 8, h bar raised to 2 by 3, m raised to minus 1 by 3, then g raised to 2 by 3. We can write it as 5 by 16, then within bracket h bar square g square by m raised to 1 by 3 plus 5g by 8, 5 by 8 within bracket h bar square g square by m all raised to 1 by 3. Now let us take h bar square g square by m and 5 by 8 outside. 5 by 8 h bar square g square by m raised to 1 by 3 is common. So let us write it as 5 by 8 h bar square g square by m. Then the remaining part is 1 plus 5 by 8 h bar square g square by m all raised to 1 by 3. Then it is 1 plus 1 by 2. Now we can write it as 3 by 2 5 by 8 h bar square g square by m raised to 1 by 3. That is equal to 15 by 16 h bar square g square by m all raised to 1 by 3. This is the expression for the ground state energy. The ground state energy is given by E, that is equal to 15 by 16 h bar square g square by m all raised to 1 by 3. Now let us check the option. Let us check the option given in the question. Now we can see that option A is the correct option.